everybody. Yeah, so Max is over there. He's going to be doing the second part of this. And today going to be talking about using database triggers to track model history. Tracking history is like this timeless classic problem that doesn't really pertain just to Django, pretty much pertains to any sort of web application or any application that's using a database. And there's quite a few Django apps out there already that aim to solve the problem of tracking an audit log or tracking changes to models. People are probably familiar with some of these, and today we're going to be talking about a very similar concept, like still solving the same problem, but solving it using database triggers. So really there's going to be two main takeaways from this talk today. First, just going to be talking about a new approach for history tracking. What does it even mean to track history with database triggers? Like, what does that look like? I'm going to go over what a trigger is for those that aren't familiar with database triggers. Just going to be talking about like some of the fundamental concepts. Why is it valuable? Why is it different than the other approaches? How can it potentially benefit you in your applications? And then Max is going to talk about other interesting design patterns that may not be immediately obvious with what you can do with a history tracking solution. So we are going to be talking about Postgres triggers specifically, and like going over a library called Django PG history. So if you use MySQL, you won't be able to use this library, but the fundamentals of the approach are still the same. It's just triggers are implemented like slightly differently across different databases. The link to the library that we're going to be talking about is Django. The Django PG history link is under this link. So I'm the main maintainer and creator of the Opus 10 open source group. There's quite a few other libraries there if you want to check them out. And again, so I'm Wes. Max is over there. He's going to be coming here. We both work at Standard Metrics, so heavy users of Django, heavy users of Django PG history, and using triggers for stuff. So just to jump right into things, though, let's just declare a simple model. So we have my model up here. It has an integer field. It has a char field. Let's say we create this model. Integer field is 2 at the beginning. Char field is high. Let's say we update the integer field to 4, and then we save it. And going back to kind of this timeless problem of history tracking, like the question that all these apps and like what PG history tries to answer is like, how do I track these changes? And it was around 2018 or 2019 when I was looking into the history tracking landscape and all the apps, and a lot of this stuff just wasn't really suitable for the needs that I had at the time at this organization I was at. Just like all sorts of just traffic, and we needed to reliably track changes. And so I started to go down the rabbit hole of, okay, well, how could I track history in a more reliable manner? And I quickly saw it's a giant iceberg. It's nowhere near as simple as it seems. And I think the two questions you have to ask first, and these are kind of the two questions that all those libraries I showed answer, first and foremost is how and where do I store all these historical changes? And you'll see some people, their first inclination is going to be, I'm just going to track the audit log in JSON. Or, I'm going to have one singular table that has the changes in JSON. And, if you want to easily query this data in your application, it can be kind of difficult. I mean, if you want to use it just as an audit log to like look at the changes, that's great, but you need to easily query it. If your tracked model, if the structure of it changes, if the types change, it's kind of hard to migrate it if you do need to do that. So another approach is you have your table that has like an integer field and a char field. Another approach is like make a structured history model. So make a history model that also has an integer field and a char field. And kind of the rabbit hole you go down there a lot of times is you end up having a bunch of different event models or history models associated with your models that you're tracking. So you got to keep those in sync. And it's just, it becomes complicated to even answer these simple questions because it depends on your app. It depends on what you're trying to do with the history. Kind of the second question, though, is how do I reliably detect changes? And this was the big holdup that I had a while ago when I was like looking into history tracking stuff, was just around reliability. Kind of the first inclination that people do, or that apps do, is they use Django signals. So pre-init, post-init, pre-save, post-save, pre-delete, post-delete. Django has the ability to like link into the model lifecycle, whether it's actually instantiating the object or whether it's saving with the database. And you can use Django signals to get like a pretty high fidelity of like all the changes that are coming through to a model, but many bulk changes like bulk create, .objects, .update, many of those don't fire signals or really fire the same types of signals. And there's inherent race conditions too with using signals. So, you have your model in the application, it changes, signals fire, you collect those changes there and you persist them to the database, but other changes might have gone on during that time. So there's just like these subtle race conditions that can happen if you're using signals. And similarly to, you might override the save and create methods, or you might require people to decorate their methods that have history tracked. And again, when we're talking about reliability and just making sure that nothing ever slips through the cracks, you have to ensure that people go through the right interfaces. It can be kind of difficult to have it work performantly across bulk operations and all this other stuff. And similar to like one thing that I think is always harder are third-party models. So imagine you install an app where you don't own the code, you don't have access to change the models easily. Like tracking changes in those can also be kind of difficult if you're relying on overriding save and create methods. So PG history in a nutshell, the way that it works, at least from a library perspective, is you install Django PG history, you add it to your installed apps like any other app, and your model, so going back to our original model definition, you just import it, you just do pghistory.track, and that's literally all you have to do. And once you have done this, what happens underneath the hood is the changes aren't tracked to some sort of model with JSON. There's actually a new model that's created entirely, and it's your event model for the model that's being tracked. So a new model is created. When you run make migrations, you'll actually see this model appear. And then any change you do to this model is tracked automatically. So let's say again, going back to our example, we create the model with an integer field 2, change it to 4, we save it. PG history, so that event tracking model is made. You have a reverse relation called .events now on your object, and you can see every value of that integer field, and it's a native integer field in the database. So we can see it was 2 originally when it was created, and now it's 4. And if you want to see all the fields, you can see char field was never changed. So along with those fields that are being tracked, there's also metadata fields in these event models. They're all prefixed with pgh underscores, so like PG history. So like the time it was created is tracked. There's quite a few other metadata fields that we'll go over that are useful, but kind of the premise here is that your events are stored in this structured model. You can query them in your application. So if you need to show history and do things, index that data, access it performantly, you can do all that stuff pretty easily. So just revisiting a little bit, like, okay, what just happened here? When you decorate a model with PG history track, it creates a completely separate model with like the exact same structure. So all the fields are there. They're named the same thing. There's additional metadata though. So like it actually creates another model called my model event. Same structure as the original model. It's almost like you're inheriting it, and then you're adding a couple metadata fields. So pgh object points to the main model. So you have your main model here. You have a totally different event log over here pointing to your main model with all the fields. And again, like the thing to keep in mind is like you're not writing this model in your models.py, it's just generated dynamically. So you can still import it like it's a model. Django still sees it as a model. You don't actually have to go create this though. If you go update my model, if you go add a new field, if you change the char field to have a different max length, all that stuff is reflected in your event model. They are both migrated whenever you change that original model. So all this stuff can be overridden and configured. I'm just kind of talking about the default behavior here of PG history. And then after that event model is made, after you've migrated it, triggers are installed on that model that's being tracked. And I'll go into what a trigger is, but triggers are installed on it. And then every time that model is inserted or updated, those values get snapshot to that event table. So you have this log of all the events. You have the log of what values that model had at that point in time for those operations. So brief overview of triggers here. I won't be able to go into it too heavily, but think about database triggers conceptually like this. You have your application on the left, you have your code, you have your Django code. It runs there in Python. You might call model.objects.create, you might call .save. Django is creating SQL, and then it's issuing that SQL to the database. So the database is hosted somewhere else. And triggers are installed in the database. So triggers don't run in your application. It's not like it's Python code that runs. Triggers actually live in your database. And so you attach them to your tables, and PG History does that automatically. So it attaches a trigger that watches for inserts, a trigger that watches for updates. So every time a SQL operation comes through and it tries to edit your main table, a trigger there will add the snapshot to that event table. So nothing falls through the cracks. You have like a level of reliability that, again, nothing falls through the cracks here. So PG History uses another library called PG Trigger to manage the triggers. So I did a talk on it a few years ago, DjangoCon 2021. So for people that want to like learn a little bit more about triggers and how they work and how you can even manually put triggers on your models, go to the library there. Like the talk is linked and like a tutorial and all that fun stuff. So that's triggers at a high level. Like that's what they mean. They're installed in the database. They run by the database. And as a result, so again, simple example here, base configuration. As a result, every change is tracked in like a structured model. You can query it in your application really quickly, easily. The model is changed. If the tracked model changes, you see it in your migrations. And your application requires like no real changes. So you can do .objects.create, .bulk update. You can modify data any way your heart desires. You don't have to remember to go through a particular interface to have your history tracked. It's just tracked behind the scenes reliably. So imagine someone goes into your database in a SQL terminal and they edit stuff. Your history would still be tracked. Is kind of like the key, one of the key takeaways here. And that's why triggers can be such a powerful way of tracking history. Just it's a very reliable audit log that runs in the database itself. So I've talked about the library at like a high level. I've talked about how it works by default. There's all sorts of ways you can configure it. I'll put the link to the library at the end though. There's like a lot of docs on how you can like really customize how it works, but I am gonna blast through just a couple frequently asked questions that typically come up when I tell people about PG History. First of which is like, what if I don't want to track every field on my model? You have the ability to specify which fields you want to be tracked. If you specify one field like we have here, your event model will only have the integer field. It won't have the char field. And if any changes happen to that char field, it won't automatically trigger an event. You have to change those fields that are being tracked. So simple way to track only specific fields. If you don't want to fire an event for every insert and update, you can override that behavior too. That's just the default behavior. You can provide trackers to PG History, and you can be very fine-grained about what events you actually store. You don't have to use it just to store snapshots on models. If, for example, you want to store an event every time my model is created and the integer field is greater than 4, you can specify event trackers to this level of granularity. And Max is going to go into some cool examples of how you can use this to make interesting event logs about things that happen in your application. But again, you can make and tailor all sorts of event logs. You can customize the underlying event model if you want. You don't have to let PG History create it for you. You can still define it in your models.py. You can add indices to the fields if you want to query them in a certain way. Like you have the flexibility to do that with PG History. And we often talk about like a reliable audit log. You can go a step further with PG History and prevent people from tampering with your audit log by just putting append only is equal to true. So what that means is that your event model itself, it'll have more triggers installed on it. If anybody tries to edit or delete it, it'll just result in an error in the database. So it's like further protection that your audit log is like a true immutable type of audit log. Like you have to go really far out of your way to ever be able to tamper with this audit log or make some sort of history that is actually not accurate. There is a default admin integration. I know that's like one of the kind of the key parts of these other libraries. You have the ability to show the entire event log across multiple event models. So keep in mind here, when you track multiple models, there are separate event tables. You can aggregate them all together in the admin. You can even query them all in an aggregate manner with some proxy models that it has. You can also make admin pages specifically for a model and just show its events as well. So basic admin integration, I would say the admin integration isn't like one of the killer features of this thing, but it's there if you want to use it. And finally, I'm going to go into more detail about this because this is a fundamental part of the library, and it's kind of like the last fundamental part I'm going to talk about. But biggest burning question is, well, I'm tracking all these events, I'm tracking all these changes. How do I associate the change with the logged in user that hit a button on the admin, or the user that was the authenticated user of an API request? And you can do all this stuff too with PG history context tracking. So again, think about it this way again. So database triggers are writing all the events. You have your application over here though with its authenticated users. You know, you might wonder, how on earth do I share data from the application with those triggers so that it can associate those events with metadata? And you can do that. Backing up a little bit, looking at our model definition again, like our event model that's generated for us, one thing I didn't say at the beginning is that there is another field on it, another metadata field called pgh_context. And it's a foreign key that's on every event model by default. And what it does is it automatically points to a centralized context table. So if you want to add free-form metadata to your events, you can. And it also allows you to group a bunch of events together. So I'll show what this means and how it can be valuable. Again, this is what the context model looks like in PG history. It's just very simple, one UUID, just the global ID of the context, and then a free-form JSON field of key value pairs that you can add and that you can associate with events. So let's imagine we have two different models, model A, model B. We're tracking them both. Again, they have both separate event models. In order to use context tracking with PG history, you go into the context manager and you add whatever key value pairs you want to associate with any events that happen within that context manager. Here, some key is the key, value is the value, and I'm creating model A and I'm creating model B. And after these models are created, you know, there's going to be two insert events that are going to be created, and they're going to both point to the same context. So here, just showing how you can grab the event, grab the context, grab that key, and its value. Underneath the hood, again, the database tables look like this. You have two different event tables. They both point to the same context. So core pieces of context tracking, again, if there are 1,000 modifications that happen within like a web request, you can go into the PG history context manager before the request. You can make all these modifications. They're all grouped together because they all point to like the same context, and you can add whatever metadata you want, such as like the logged in user. And Max will go into some examples of that. I'm just talking about how it works at like a fundamental level, like what this actually even means. And before we go into like some more interesting design patterns and stuff like that with PG history, one just final note about context. So everything in PG history is just set up to be built with performance in mind. So when you go into PG history context, if you add it, if you nest it, you can nest it as many times as you want. It's not making queries or anything like that. You don't have to worry about it accidentally making 1,000 queries. When you go into the context manager, it just aggregates data in like a global type of variable. And anytime the modifications do happen, that metadata is sent alongside the SQL as a variable. So like that's kind of how it all happens underneath the hood. And when those triggers fire, they just associate the metadata with the event. So it's pretty simple how it actually works, but there's a lot of magic going on behind the scenes to attach that SQL and to make sure that you don't accidentally blow up your API request with a ton of queries because you were adding a bunch of context. So that's kind of how it works. You don't have to worry about additional round-trip database queries. So with that being said, Max is going to do the second half of this talk, and just going to be going over some interesting design patterns that you can do that may not be totally obvious with like PG history or just history tracking stuff in general. I think you'll be going a little bit over the context tracking stuff again. So yeah, this is Max.
Thanks, Wes. Hey everyone, Max, work extender metrics with Wes. It's kind of funny. The original reason we actually met was because, I was trying to solve this history tracking problem at standard metrics. And so that's originally why I reached out to Wes and how we ended up working together. But I'm going to go over some cool design patterns that you can sort of achieve with PG history. I think there's a lot of things in this library that are really achievable outside of your standard audit logs for tables, right? There's a lot of other cool things and want to make sure you guys know about them and can, maybe come up with some other cool ideas and ways you can use PG history. So the kind of first one is going to be default context tracking, right? So what do I mean by this? So, as Wes just went over, you can instrument this context tracking, throughout your application, right? So just use this context manager, as a decorator or as a context manager, and you're really able to associate any data you want in this context table with events. But there might be a lot of other places in which you want default, context tracking, right? So maybe within the lifecycle of an API request or within a celery task or a base management command. And you want to understand how those events were created, right? I've seen this before, right? Where maybe you're creating an object in a variety of different ways. Maybe there's some bulk process action in a task, but it can also be created within an API request, and you want to understand how it originated. This can not only be useful for maybe, finding ways to kind of represent that state on the front end of your application, but also maybe just for debugging purposes, right? You want to understand, okay, the object originated from this task or from this management command, and you can do that. So, one of the cool things that PG history actually offers out of the box is just default context tracking, via middleware. So there's this installable middleware you can just add to your settings, and by default, this will just then, for any events created within your API requests, will add in the user ID and the URL. So quite easy to get this set up by default, right? Obviously, if there's additional things that you don't want to track, in your middleware, you can sort of create your own custom middleware that just uses PG history. But if you just sort of want to base, user and web request URL, you can get that quite easily. As kind of Wes alluded to earlier, this will aggregate all the events together for this kind of context table that's being created, right? So we're going to be able, we're not going to sort of have a context per event, but rather context for all the events created, within these API requests, right? So kind of going over that example I mentioned with celery, right? Like, what if we want to instrument base context tracking within a celery task, right? So, let's say we're overriding the base celery task, right? We can just sort of add in, the context manager here and grab the task name. And then that's going to easily let us, regardless of whether we're using PG history not within celery task, right? Any events created in celery task will then be associated with context for the task, right? And kind of a quick example with this, like, let's say we just have some task that processes some type of payment order, right? So let's assume all these objects have event tracking enabled, right? So order, payment, shipment, they all have kind of the base PG history tracker. Sort of what we have now is this ability to understand that all of these objects were created from the same task, right? So these are all these sort of event instances are going to foreign key back to the same context instance. And we're going to be able to understand that these all came from process order. And, kind of going into sort of this further, it's also possible for us to stack context tracking, right? So maybe there's some additional data you want to grab in the celery task. Maybe, for example, the user ID, right? So let's say the celery task is being kicked off from inside, an API request, and we're passing in the user ID who kind of initiated this. We can also just add that in. And what's going to happen is, instead of two context instances existing, these are going to get aggregated into the same context, table instance. So that way we don't, you can sort of, you don't have to worry about extra queries here or sort of any performance implications. It's really easy. You can stack this context as much as you want and really not worry about it. And it's all sort of going to be aggregated cleanly for you. And so, yeah. Kind of going into another design pattern that can be quite useful is this ability to go back to previous events, right? So I'm going to walk through an example here of sort of a use case in which you might want this, but I'm sure there's a lot that you guys can think of. So let's say you're building a CMS, right? So something like WordPress or some type of, admin, application where you want users to basically have this ability to go back and see all edits they've made to blog posts, right? So users are creating, editing, managing blog posts, and you want to be able to just go back and visualize those edits and see sort of how the post has progressed, right? So we sort of have this simple table here for a blog post, and we just add a history tracker onto it. And as simple as that, right? Now what we effectively have our fully captured updates and creates, and we can really understand, all the blog events that sort of occur. So every single edit, to the content, but also any of the other fields are going to be tracked here. And we're going to then be able to surface this information to users however we like and easily have that with really just a single line of code. But what if we want to give users the ability to then revert back to one of these previous blog posts, right? How can we do that? Well, what's super cool is actually the base event model. So basically every single, events are going to kind of be derived from this model, has a revert method. So, this revert method will basically return the original object type that this event is for, and will sort of revert based on the chosen event, right? So this is pretty cool. So what we can do here is go ahead and add, implement our own revert method on blog post, just take in the version ID. The events is the default reverse relationship name for all of the associated events, and then we can just call this method, and there you go. We're sort of going to do we're just going to update the existing instance, and then we'll sort of have that blog post reverted to its previous state, sort of while maintaining this full audit log of all of the edits still. So this is pretty powerful to set up. We can even create a simple DRF API for this, right? Just call the method on post, just grab it, and there you go, right? Sort of with sort of less than 15 lines of code, you've effectively set up full history tracking for these blog posts and also the ability to go back to historical blog posts. And sort of one caveat here is obviously you want to make sure that you're tracking all of the fields for the table, as if there's anything missing, you're not going to be able to go back and revert. So make sure you're tracking all the fields and you're not excluding any if you want to use this functionality. Another cool thing I'm going to be talking about here is soft deleting models, right? So this is something that I've actually used PG history for, that initially I didn't think of as sort of a main application or something that I'd want to use it for, but I ended up finding it quite useful for this use case for a variety of reasons that I'll go into. But to kind of like talk about soft deleting Django models in general, maybe it's a problem you all have seen, but it's kind of a tricky problem to solve, right? There's sort of this naive approach, which is you kind of use a simple Boolean flag to indicate whether a model is being soft deleted. And this works, but it has its issues, as you can assume. So let's say we have blog posts, right? And let's say we want to soft delete this model, right? So maybe we want to give users the ability to restore deleted blog post, right? And we can just have it in its deleted field. It defaults to false. We override the delete method, and instead of doing an actual delete, it does a save and just sets this field to true, right? So at this point, right, we can then just go into the base override the base manager, create our own blog post manager, and override get query set, and then just filter on sort of non-deleted blog posts, right? And this works in practice, but it kind of has several issues. One is like when we're filtering, we're not going to sort of exclude default objects when filtering on reverse relationships, or just generally when we're creating a query object, right? It's one of those things where it's up to developers to remember to filter on deleted objects every single time. And this may not be a big deal if you're working in a small code base, but for larger code bases, this can be a little bit, it can be sort of, you can have gaps, right? Is I guess what I'm trying to say. And then also sort of, you're not going to get proper cascading deletes, right? That's just another issue as well. So kind of nothing, and also nothing just stops us from hard deleting the model and getting around this delete method, right? So we could do a filter and then a delete, or we could, just sort of write raw SQL and delete the object. So there's nothing really stopping us from, we're making it harder, right? And we can just kind of try and patch all the ways in Django that you could delete it. But at the end of the day, it's still deletable. So yeah. So PG history, as Wes chatted about, is actually built on a library called Django PG trigger. And there's this kind of interesting middle ground approach that's still based on triggers, but sort of lets us take this field-based approach to filtering out objects that works, in my opinion, a lot better, and solves one of the issues around cascading deletes. So sort of the way, I'm not going to spend much time on this, but the way Django PG trigger works is you can basically set up triggers in the class meta. So here, PG trigger actually is like a built-in soft delete trigger, and we just specify the field that kind of represents whether the model is soft deleted, and we tell it to, say, hey, flip it to true, right, upon a delete. And so this sort of what will happen now is whenever the model is deleted, regardless of how it's deleted, no matter what delete method you're using Django, whether you're writing raw SQL, this field will get flipped to true, right? Because it's being set up by triggers. So this is not something in your Python code. This is sort of happening at the database level. And so this first of all solves that one problem I mentioned here about making sure you're always flipping this field. And then it will also sort of Another cool thing this will do is it'll actually cascade delete other models, right? So if there's any model foreign keying to blog post, this trigger will still sort of have that model be cascade deleted, which solves that sort of problem that we saw there. But we're still left in a state where you do have to filter out the reverse relationships, which depending on your use case may sort of be inconvenient. This is a difficult problem to solve, and one I tried to solve. There are ways to do it kind of, you can, on sort of traditional reverse relationships, there's sort of a way to maybe work around it, but like, it then becomes hard to get the deleted objects if you ever want them, and then it's nearly impossible to do it on kind of, queue objects and whatnot. So it's really sort of a difficult problem to sort of work through. And kind of like I was just saying, right? So every single time, whether through like a direct foreign key or a reverse relationship, we're actually just going to be including deleted objects here, right? Which is not what we would want, and maybe not what other developers would expect unless there's kind of this established pattern of soft deletes in sort of the code base. And so sort of using PG history to solve this problem, actually can work quite well, because what we're going to end up doing here is storing the soft deleted model in a different table. So we're not worrying about filtering out these objects or anything like that. And it also solves all the sort of problems around cascading deletes. So I talked about how, using Django PG trigger, we can cascade delete other models, but the model itself can still not be cascade deleted because the deletion status is being represented by that field. So you just basically no foreign keys that live on blog posts can lead to a cascade delete of blog posts. You just need to make sure they're like set null or sort of protect. But with this approach with PG history I'm about to go into, we don't have to worry about any of those concerns. We can the table will sort of operate almost as if it wasn't being soft deleted, but you're still going to get soft deletes. So kind of now here, what we're going to do is actually add a second tracker. And this is because we want to store this in a separate table, right? So we can just add a second tracker here for a deletion event, and we'll specify the model name is just deleted blog post. And so now whenever this blog post is deleted, we're just going to store the deleted instance and deleted blog post. And this will sort of solve all the problems around cascading deletes both ways. So this model itself, like if the author gets deleted, this table will just get cascade deleted and we'll create a deleted blog post. So no restrictions on sort of how you set up your foreign keys, no restrictions on models foreign keying to this, and you never have to worry about filtering out those deleted objects, right? You can always still get them if you want by just querying on the separate table, but yeah. So, and you're still going to have access to the sort of primary key on that table if you want to filter on it by that. But, basically just what I mentioned here, right? Cascade deletes that work both ways, and that ability to make sure we're always excluding soft deleted objects. And now we can even create a simple endpoint to restore a deleted blog post, kind of like we had with reverting to previous blog post. We can just sort of, grab the deleted blog post. Revert does update or create, right? So in this situation, we're just going to, be creating a blog post here, right? A new one. And then we can serialize this and return the data. And there you go, right? Like once again, with sort of less than 15 lines of code, we've sort of been able to now have soft deletes on this table with, a lot of these issues mitigated, and also be able to go back to deleted instances, right? This hypothetical, content management sort of system now has sort of a lot of this functionality that traditionally would sort of be difficult to get to. The next thing I'm going to go into here is kind of like use cases around foreign keying to event models. And this is useful because it can really be helpful to understand a model at a given point in time without having to just, add additional fields to that table to understand it for, at a higher granularity. So kind of like an example I'm going to talk about here is like, let's say that we have maybe some fantasy sports application, right? And so we're tracking like football games. So we have a home team and an away team. And we want to we also have another table that effectively tracks the win-loss record for a given team in a season, okay? And, we want to understand the win-loss record for each team for a given game. What can we do here, right? Well, obviously you could just denormalize the data onto the table. That will work. But what if we just want to keep all the information within this table, right? We can just add history tracking here, right? So for inserts and updates, we're sort of going to have history tracking now. And now we can just foreign key to this table to understand the win-loss, ratio at a given point in time, right? So we can keep all the data in this table. We don't have to denormalize everything. And whenever we query from this table, we can get the most up-to-date, win-loss ratio, for a season, but we can also sort of understand it at any historical point in time, right? So this is sort of a pretty useful use case of that. And kind of, and as I just said, right, like the alternative would maybe you could just track the sort of win-loss, record for a season at you could just store it for, you could just have it, directly point, to the game, or just have a date field on it. But with this, you don't even have to worry about that, right? You can just store it every single time it changes and link it with the given game. So this is pretty powerful. And sort of the last thing I'm going to go over here is kind of application-specific event logs and kind of going into some of that custom, history tracking that Wes mentioned and some useful applications of this. So sort of an example I'm going to give here, right, is sort of like, say we have a bank account model, right, that has a balance. What if we want to send out an email to users if their bank account balance goes below 0, right? Something that a lot of banks are going to want to do, right? So what we can do is just add in a history tracker, and we can sort of have an update event on the condition that the balance is less than 0, right? And we'll store this in a table called overdraft event, okay? So every single time any account goes below 0, this is what will happen, right? And let's say if we want to understand the sort of state of whether an email was sent out, we'll just have this kind of simple table that will one-to-one with an overdraft event. Basically, if this exists, it means the email was sent out. And now what we can do is just have a seller task that filters on these events that don't have this object, this sort of one-to-one object existing. And then we can send out those emails and then create the object, right? And so what we have here now is sort of almost like an eventually consistent type of task that will sort of, if there's no emails to send out, it's just going to be a no op. But if there are, you're sort of always going to ensure that you have those all sent out. And the kind of alternative here would probably be to just, you could maybe instrument some like custom logic, right? Like maybe in the save method or something where, okay, if the balance goes below 0, you like send out an email using salary, or maybe you probably want to do it asynchronously, right? But the issue there, right, is like, what if the salary pod dies? What if there's some transient error? Then you have to go into SendGrid or whatever you're using for managing your emails, and then see that email wasn't sent, and then see about getting it resent. With this, even if the salary pod dies or there's some transient error, then this task can just rerun. We never would have sort of created that email sent object, and we sort of understand, right, that we sort of have we have a good understanding of what emails are sent and which were not. So this is sort of but even just beyond this, right, just being able to understand these events is useful for a lot of other things outside of, just sending out emails, right? So some really cool stuff we can do with kind of this conditional tracking. But yeah, that's basically it. Huge thanks to the DjangoCon organizers, as what's coming up here. But, as we mentioned, we both work at a company called Standard Metrics. But if you want to contact us, we have our personal emails here. And if you want sort of to see Django PG history or also Django PG trigger, go over to Opus 10 on GitHub, and you can see both of those repositories there.
I was going to mention too that we'll answer questions out in the hallway as well.
Yeah. Awesome. Thank you, everyone. Thank you.